So how can we tell whether a relation is a function? Well, we've seen one way already. If we're talking about a mapping, a function will take each number in the domain and map it to exactly one number in the range. Each arrow is going to just be a single arrow from the one number to the next number. In a relation that is not a function, we get this splitting effect. We see that some of these values in the domain are paired with multiple values in the range, and that's represented in the map by this split going from the left to the right, from the first set to the second set. And it is that split that prevents this from being a function. Let's see a third example. The example given by the equation y equals x squared. If we start to fill in a mapping, we see if I put in 0 for x, what can the corresponding y be? Well, there's only one way to square 0, and that's 0. And so 0 gets mapped to 0. Okay. If I put in 1, what can this corresponding y be? Well, 1 squared is 1. There's nothing else that 1 can be mapped to. However, what if I take -1? -1 squared is also going to be 1. So both 1 and -1 are in the domain are paired with 1 in the range. And we see this again. 2 and -2 are going to both become 4 when we square them. So again, both of these are mapped to the same number in the range. However, that is perfectly okay. This is a function. And the reason is because a function assigns exactly one range value to each domain value. Well, each domain value is only going to one range value. It doesn't matter that each range value may be assigned to multiple domain values. So the fact that these mappings are coming together in the range side is okay. It's only if we have a split on the domain side that it fails to be a function. So we've seen how to tell whether a relation is a function if we represent it as a mapping. What if we represent it as a table or as a set of ordered pairs? Well, remember, for this relation, we can fill in some numbers, and when we fill in the table with our values, we see something. 0 is paired to 0, that's fine. But then when we get to 1 is paired with 1 and 1 is paired with -1, that split that prevents this from being a function, what we notice is repeated first coordinates. And that is how you can tell on a table that the relation is not a function. On the other hand, if we look over here at the set depiction of it, we really see the same thing. Okay? When we list the ordered pairs, we see a repeated first coordinate. So if we have a repeated first coordinate either in a table or in a set of ordered pairs all listed out, then that tells us that the relation cannot be a function, because it means that a number in the domain is being paired with two or more numbers in the range. On the other hand, this example that we already saw is a function. When we look at this, remember, in this one, we had two different domain numbers being paired with the same range number. And we said that was okay. So repeated second coordinates are okay. Repeated first coordinates indicate the relation is not a function. And again, it's the same when we're talking about the set of ordered pairs. We see there's a repeat here in the second coordinate, but that is fine. This is still a function. Now let's think about how we can tell if a relation is a function by looking at its graph. We saw this graph earlier. And here next to it we have the graph of our second relation that we looked at. We talked about how this first relation is a function and the second relation is not a function. What about the graph tells us that? Well, remember, a function is defined in such a way that every x value corresponds to exactly one y value. So if I find an x value, okay, say I pick the x value 1, the x value 1 corresponds to this line right here, x equals 1. And we see that it intersects the graph right here in this one point, and so that corresponds to exactly the y value of -3. Whereas over here, if I were to pick the x value -1, what happens is that line intersects the graph in these two places, corresponding to two different y values of 1 and -1. And so I have one x value being related to two y values, and that means this cannot be a function. And so we see that if a vertical line intersects the graph of the relation in more than one spot, then that relation cannot be a function. We call this the vertical line test. Explicitly stated, the vertical line test says if every vertical line intersects the graph of a relation in no more than one point, then the relation is a function. Here are a couple more examples of the vertical line test. For the relation on the left, y equals x squared, this is another one that we looked at before, and now here's the graph of it. We decided that this is a function, and we can verify that with the vertical line test because we see if we pass any vertical line through it anywhere, the vertical line is going to strike it in only one point, no matter where we set our vertical line at. Okay? So that confirms that this is a function. Notice that if I pass a horizontal line through it, it will strike it in two places. But that's okay. That's just like in the mapping when the two arrows come together. That's exactly what's going on. But that still does not prevent it from being a function. So it's only a vertical line that will determine whether it's a function or not. Now, what about the domain and the range? Remember, the domain is the set of x values. In other words, what values can I get going left to right? Well, these arrows signify that this curve is going to continue up and to the left forever. So we get everything to the left. And this arrow signifies it will go up and to the right forever. So we get everything to the right. So everything from left to right means all real numbers, the interval from negative infinity to infinity, just like we saw in our first example. However, the range is different from our first example. The range will be the up and down values, the y values. So what up and down values can we get? Well, again, the arrows point up, so it's going up forever. So we know the right end is going to look like that. However, what is the minimum value? It only goes down so far and stops. It can only come down to the value 0. And so the range is not all real numbers, but rather the interval from 0 to infinity. Now here's another example. This is supposed to be a circle, and so the question is this a function or not a function? And the answer is clearly that it's not a function. If I were to pass a vertical line through it, it would strike the graph in 2 places. Not everywhere. If I pass it just along the edge here or here, it will only strike it in 1 place. But if even one vertical line intersects the graph multiple times, then it's not a function. It fails the vertical line test. What are the domain and the range of this relation? Well, left and right is the domain. It can go only as far left as the x value 0, and only as far right as the x value 6. So the domain is the interval from 0 to 6. The range, again, the y values, the up and down, can go as far down as negative 3, and as far up as 3. So there are the domain and the range of this relation.